Hello and welcome to our lesson for today. So for today, we will be talking about radicals. So for our week 2, module 2, it is about the radicals, and here we will encounter words such as the radical sign and the radicand. So for our basic properties of radicals, we have if A is greater than or equal to 0, and n is odd, then the nth root of a raised to n is equal to a. Next, if a is greater than 0 and n is even, then the nth root of a raised to n is the absolute value of a. If a is greater than or equal to 0 and b is greater than or equal to 0, then the nth root of a times the nth root of b is equal to the nth root of a times b. And for the last one, we have if a is greater than or equal to 0 and b is greater than or equal to 0, then the nth root of a over the nth root of b is equal to the nth root of a over b. So now, let's perform the following operations. We have square root of 3 multiplied by square root of 3. So since you are multiplying two square roots, the answer would be square root of 9. So you just have to multiply the numbers inside, and then the square root of 9 is also equal to 3. Since n is even, because the value of n here is 2, since it is square root, we are taking the absolute value of the square root. Next one, we have square root of 7 times square root of 4. So 7 times 4, 7, 14, 21, 28. So we have the square root of 28. But we can still factor out 28. So when we factor out 28, it would give us 7 times 2 times 2. And we could take out 2 from the square root. So our final answer would be 2 square root of 7. Next one, we have square root of 60 over square root of 6. So we can put them in just one square root. So we have 60 over 6. So that would give us 60 divided by 6 is 10. So our final answer would be square root of 10. For the next example, we have 2 square root of 5 times 4 square root of 5. So we would just multiply the numbers outside the square root and the numbers inside. So you have 2 times 4 is 8. 5 times 5 is 25. Since 25 is a perfect square, we can take 5 out. So you have 8 times 5 or 40. So our final answer is 40. For our next example, we have a negative number. So we have 5 square root of 10 times negative 2 square root of 2. We just have to multiply them. So you have 5 times negative 2 is negative 10. 10 times 2 is 20. factor out 20, we would get 5 times 2 times 2. And we can take out 2. So we have 10, negative 10 times 2, square root of 5. So our final answer would be negative 20 square root of 5. Now let's proceed to our rationalization part. So to rationalize the denominator containing a binomial radical, we must be able to multiply the numerator and the denominator of the fraction by the conjugate of the denominator. So here is an example of a conjugate. So let's simplify and rationalize. So if you have square root of 2 over 5 minus square root of 2, we multiply it by its conjugate. So that's 5 plus square root of 2. It would give us 5 plus square root of 4. And then from the bottom part, we will use the FOIL method. So we have 5 times 5 is 25. 5 times So our final answer would be 9 over 23. For our next example, we have square root of z minus w over square root of z plus w. So we multiply this by the conjugate, so we have square root of z minus w over square root of z minus w. So our answer would be, let's use the FOIL method. So our final answer would be z minus 2w squared of z plus w squared all over z minus w squared. Now let's proceed to adding and subtracting radicals. So to perform these operations, the numbers inside the radicals must be the same. So let's have our examples. So you have 3 square root of 2 minus 2 square root of 2. So as you can see, the numbers inside the radicals are the same, so we can subtract them. So 3 minus 2 is 1, and then copy the radicals, which is square root of 2. So it's okay not to write 1 already, So our final answer would be square root of 2. Next one, we have 6 plus square root of 5 plus 2 square root of 5. So 6 plus 2 is 8, square root of 5. How about this one? We have square root of 27 plus square root of 48 minus 2 square root of 3. First, we need to factor out our numbers and see if we have some radicals that can be the same. So 27 is 3 times 3 times 3, while 48 is 2 times 2 times 3 times 2 times 2. So when we simplify this one, this would be 3 square root of 3, and this would be 4 square root of 3. So we will be using 4 kasi it is square root. So we just have to use two numbers to take out in our radical. Now, all our numbers have the radical square root of 3. So we can now perform the operations. So 3 square root of 3 plus 4 square root of 3 is 7 square root of 3. Minus 2 square root of 3 is 5 square root of 3. So sometimes there are instances that we need to simplify first our radicals before we proceed to the operation itself. So that ends our lesson for today, and I hope that you learned something new. If you have other questions or clarifications, you can always ask me and I will be more than willing to help. Thank you very much.